Welcome back, pre-calculus students. Right now we're going to be looking at a tool that's very useful in pre-calculus, especially in factoring, but it also happens a lot in calculus, and that's kind of why we're going over it. It's kind of setting you up for the class you may be taking next year. It's the process of replacing an algebraic expression with a single variable. This is called U substitution. U substitution. It's only called U because we typically use the variable U. I mean, I guess you could call it R substitution if you want to use R, but typically we use U. It's a very helpful technique, again, especially in factoring. A quick example is something like 3 times the quantity x minus 5 squared plus 2 times the quantity x minus 5. Although this one may be a little bit more, easier to see, there's a common expression here in x minus 5. Rather than trying to factor out that x minus 5, what we're going to say is u equals x minus 5. So now we're left with 3u squared plus 2u. Now this is a lot easier to factor. It's a single variable. We're going to pull out our single u, and we're left with 3u plus 2. Now at this point with u substitution, we do have to plug it back in because everything we have right now is in terms of u's. We need it in terms of x's. So wherever there's a u, we're going to plug in x plus 5. Sometimes when you do this, you're left with, like in this case, 3 times x minus 5. You're left with 3 times x minus 5, and you probably want to distribute that just to get it down so you can combine like terms. So you're left with x minus 5 times 3x minus 15 plus 2, which is the same as x minus 5 times 3x minus 13. That's the basic process for u substitution. Now, taking a look at some more complex examples and some things we saw previously with special formulas. If we take a look at 25 minus the quantity of z plus 5 squared, we're going to start by assigning what our u variable is. In this case, it's going to be u equals z plus 5. When we let u equal z plus 5, we're taking an entire expression, z plus 5, and replace it with a single variable. We're left with 25 minus u squared. This is the difference of squares, one of our special formulas. We could say 25 minus u squared is 5 plus u times 5 minus u. Again, that is factored, but it's in terms of u. We need it in terms of z's in this case, so we're going to substitute back in 5 plus z plus 5 times 5 minus z plus 5. Simplifying a bit, combining like terms, we get z plus 10 times the quantity of negative z. If you want to write that in a slightly different form, you can pull that negative z out front. This may be something the back of your book may show for on homework. Now, the reason we're not going over all these problems is some of us are doing this in class, some of us are doing it on the video, so we're going to skip down 2 problems to take a look at a couple other basics. The next one, 2x to the 4th minus 2x squared minus 3. This looks a little bit weird, but we're really fitting into, this is almost like a basic factoring problem. X to the 4th and x squared is kind of throwing us off. Typically that's x squared and just x. That may be a hint that u substitution is a good step. In this case, we're going to say u equals x squared. Now, the reason why we did that is because x squared squared gets us that u to the 4th. So what this becomes is 2u squared minus 2. Oh, excuse me. This is a problem that we're going to change just to make it a nice, easy factor. We're going to get rid of that 2. So it's just going to be minus u squared minus 3. I know, don't you love when teachers do that? They have the power to say, hey, this problem's going to be a lot easier if we just get rid of it, so we're going to get to do it, and you don't get to do that. I know, sorry about that. I forgot to change it at the beginning. When we factor this, either by I'm going to use by grouping. A times c gives us negative 6. Factors of negative 6 that add together to give us negative 1 are negative 3 and 2. So we have 2u squared minus 3u. Excuse me, this should also just be plain old fashioned u plus 2u minus 3. I'm going to group. Pull out a u here. 2u minus 3 plus There's only a common factor of 1 in our next term. So we're left with u plus 1, u plus 1 times 2u minus 3. We're going to plug our u value back in, which is x squared. So we have x squared plus 1 times 2x squared minus 3. For our last example we're going to take a look at is D. D, we're going to let the expression u equal x minus 2. That leaves us with 4u squared plus 4u minus 3. We're going to factor this like a normal trinomial. A value times C value gives negative 12. Factors of negative 12 that add together to give you positive 4 are positive 6 and negative 2, which makes this 4u squared plus 6u plus a negative 2u minus 3. Group. 2u is common in the first two terms. You're left with 2u plus 3. Negative 1 is common amongst the next two terms. You're left with 2u plus 3. So your final factor is 2u minus 1 times 2u plus 3. Substitute our x value back in, and you get 2 times x minus 2 minus 1 times 2 times x minus 2 plus 3. And there we're just substituting our u value back in. We're going to distribute, start combining some like terms. 2x minus 4 minus 1 times 2x minus 4 plus 3. And our final factor is 2x minus 5 times 2x minus 1. So again, u substitution, take any expression that's kind of complicated, a little harder to work with, plug in a single variable. Typically we use u, and that's why it's called u substitution.